Ladies and gentlemen, boys and girls, children of all ages. Now, we've done a short video on this before, multiplying by powers of 10. You've been doing multiplication of powers of 10 probably for the last 2 years. Because if I gave you this number, DJ, this problem, what's my answer? She's got her shoes off. She's counting. What's the answer, DJ?
3,700.
Not 3,700. Joe.
For which one? Oh.
37 times 10.
370.
370. Now, probably you were just told, hey, just throw a 0 on the end. But that's not quite what you were doing. What you were doing is you were making each place value 10 times bigger than it was. And by doing that, you're removing the decimal point. Okay, because 37 does have a decimal point. It's after the ones place. So if I have 7 ones, and I change it to 7 tens, 7 tens is 10 times greater than 7 ones. So really what you're doing is you're moving the decimal point to the right once, because I want to make it 10 times bigger. I don't think that's going to work. And that is how it becomes 370. Because I went from the 7 in the ones place, which is worth 7, to the 7 in the tens place, which is worth 70. So it is 10 times greater. The 3 in the tens place, which is worth 30, the 3 in the hundreds place, which is worth 300, which makes it 10 times greater. So that's what you've been doing. You've actually been moving the decimal point to make the number 10 times greater than what it was. Or 100 times greater. Or 1,000 times greater. All you've really been doing is moving the decimal point so you can move the place values of where they're at. I'm just saying. So now, obviously, when we multiply a number by 1, it's the identity property, I think, and it stays the same way, right? Now, 10 is greater than 1, so that means we make our number greater. It's 10 times greater. It is 10 times greater. So to make the number 10 times greater, I'm moving my decimal point to the right one place. To make a number 100 times greater, I move my decimal point 2 places to the right. Guess what? When I want to make a number 1,000 times greater, I move my decimal point 3 places to the right. Which means I have to add a 0. Because my 3 needs to be 1,000 times greater than it is. 3 ones is 3. 3 is now in the thousands place. 3,000 is 1,000 times greater than 3 ones. So moving the decimal point makes my digits, each place value, is 10 times greater than the one behind it. Okay, so it's moving a decimal point. But because I'm Jackson's favorite teacher ever, I'm teaching you the reason why. Because we're making our place values 10 times greater, or 100 times greater, or 1,000 times greater. Now, obviously, multiplying by 1, the identity property, and so that number stays the same. I think it's called the identity property. We'll have to look that up later. That's a good question. Let me ask you this question. Joe, 1/10, less than or greater than 1?
Greater.
Joe, 1/10, less than or greater than 1?
Oh, less.
Less. It's got a 0 in the ones place. It has no ones. No ones. 0 ones. It has 1/10. This would be like it'd be 1 dime, which is less than $1. So if I multiply by a number greater than 1, this factor gets bigger. If I multiply by a number less than 1, this factor gets smaller. And again, these are powers of 10. They're just 1/10 is actually the opposite of 10. 1/100th is the opposite of 100. And 1,000th is the opposite of 1,000. So we're going to do the exact opposite. Because now I want to make my 2, I need to make it 10 times smaller, or 1/10 of what it is now. So I need to move it from the ones place to the tenths place. I'm just moving my decimal point to the left once. Here, I'm moving my decimal point to the left twice. For 1,000, I'm moving my decimal point to the left 3 times. And if I multiplied by 1/10,000ths, I'd move it 4 times, which means I'd have to put a 0 in front of it if I needed to. Now, some people are like, this is a trick, man. It makes life so easy. It's not a trick. There's a reason behind. And the reason behind is because we're trying to make the number that much greater. But if I did the actual math, let's take a number real quick. If I did the actual math, that's what I'm getting. So if you understand the reasoning behind it, like 7 2/10 times 10. If I do the actual math, I'm going to get the same thing. 0, 0, 0, 2, 7, 0, 2, 7, one number behind the decimal point, and it becomes 72. But now I don't have to go through all this. If you understand why it does, what it does, when it does, and where it does. God bless you. Thank you for having me remind the students how to do this. You're a wonderful young man, Jackson. It's an honor to have you in my class. Way better than Luke. Boom, shakalaka, peace out, God bless, love you. Do something kind today, save the beat. Please subscribe.